Yeah. Good evening, Sir Sean. Sir, good evening. Sir Sean? On the microphone up there. No.
Yes, Shana, good afternoon.
How are you, sir?
Good, thanks. How are you?
I don't know. I'm here. So
You're alive. You're alive and well.
I'm alive. I wouldn't say well, but I'm alive. This week has been hectic, and I know the weekend coming up, and you're going to tell us when the mid-semester is coming up, and we're supposed to be finishing the assignments before then. So apart from Saturday and Sunday, I'm definitely setting out to start doing the actual homework and the exams. I was very hesitant, but I think I've worked through some of the kinks, and I think I am more assertive now.
Okay.
Sorry?
I'm saying, okay. So, well, let's see what will happen then now. You said this document not what you say. I think it's correct.
Sorry?
You don't hear me?
No, you're talking as fast as I'm talking, so no, I wasn't hearing you.
So, you talk faster than me, hear me. Talk faster, you can't hear me.
All right, I have a hearing problem, so.
No, I'm saying, let us see how it will work out.
All right, sir.
Right, cool.
Thanks.
No, no problem.
Good evening. Hi, Shauna. Welcome back. I hadn't seen her online for a good little while.
Right, Shauna, thank you.
Yes, number 16. Oh, come on. Mm-hmm. You know what? Let me get this thing up. Let me get this thing up. And while we wait on the others to join, you guys can do something for me. Uh, this is Kepler's.
Sir, sir, Mr. Sean.
They calling me with such attitude. I thought I was unmuted. So I'm answering. What's up?
Hi, sir. Question, please. When is your mid semester?
This positive has to do. Do you know?
And the lesson, the new topic that you that was taught on Tuesday, right? Will it be on the mid semester?
No.
You said no.
I said no, right?
Okay, and will you send the recording?
Yes.
All right, thank you.
You're welcome. All right, so I'm giving you a warm up right there. All right, clearly this, I'm getting a feedback. Hold on. Let's see.
All right, so I had to step away, and I'm going to step away for another 5 to 10 minutes, sir. It's beyond my control. So this is what we need to work out now
Yeah.
using the product function. All right.
Come on, why is this thing getting so annoying? I should just kill this and then just restart it now first. I'm seeing potential problems with one of those. Oh man. Are you guys seeing the screen?
Yes, sir.
Okay, good. Start working, please.
Okay, sir.
Lord. Okay.
Good afternoon, sir.
Good afternoon to you, and how are you?
Not. Can you mute your mic?
Okay,
Thank
sure, no
you.
problem. No problem, will do. You guys finished now?
Sir, I was kind of confused a bit, and I think I'm working through it. I think I went somewhere. I went wrong because I don't think I'm supposed to be having these big numbers, but I got to the point where I have 21x squared plus an open bracket 42x to the fourth plus 12x, and I'm not sure if I'm on the right path. I think I've
All right.
confused myself.
All right, no problem. Is there anybody else that got somewhere? Let me hear what you think.
Attempt finish. I just hoping that it is right.
Good. So I'm hearing that. Where am I sharing from? Oh, no, this is. Okay, so it's back up more then. So, okay, so let us see what will happen now. Find you by dx. So I'm gonna have the first. I'm calling this one here the second. So I'm gonna have the first divided by dx is the first, which is 3x squared, times the differentiation of the second times 6 times 7x to the fourth plus 2 raised to the fifth power. Do you all agree with that step so far?
That's not how I have it written, but yes, I have, yeah.
Anybody else?
On the other end.
That's fine. Anybody else agrees with that step so far?
Sir, where you got the fifth power from?
You put the 6 up there and bring it
You minus 1 from the power. You subtract 1 from the power. And then what is left to be done? What is left to be done with this question? Talk to me now.
You multiply the thing, Art. We
Times
have
what?
3x times 3x squared times 6. That's 18 squared, correct, sir?
I have to multiply it now by the differential of what is inside of the parentheses.
So it's 7 by 5.
7 by 4. 7 by 4.
7 4s,
4 7 is 28. 28 x to the third.
Oh, me get this wrong.
Yeah, me too.
Because remember, you know, I have to differentiate what is inside here now. And the differential of that goes to 0. And the differential of this will go to that. All right. So when I get 4 times 7, I get 28. 28x to the third power. So that's the first times the differential of the second plus the second, which is 7x to the fourth plus 2 raised to the sixth power times the differentiation of the first. What's the differentiation of the first?
326. Well, yes, if we're aiming for this line, not the top line, Lord Jesus.
What's the differentiation of the first?
326. The first one, Art. When you say first, sir, you mean the one that comes after the equal?
What,
we have
what is the differential of the first? It is written on the screen. What is the differential of the first?
It's 42.
No, ma.
Mm-hmm.
Come on. What is the differential of the first? Look at the
6x, sir.
Thank you, 6x. Tashana, you were saying 6.
I had 6x at the end round there, yeah.
All right, thanks, Cole.
2, 3,
So now,
Yes, sir.
so dy by dx is going to now be equals to 20. What is 28 times? What is 28 times 6 times 3?
28 times 6 times 3.
504.
Very good. So I'm going to get 504x to the fifth times 7x to the fourth plus 2 raised to the fifth power plus 6x times 7x to the fourth plus 2 raised to the sixth power. Anybody agrees with me with that line so far?
Yes, sir.
All right, so we need to look at what is common. As 7x to the fourth plus 2 raised to the fifth power is common. Remember, we take out the lower of the 2. So dy by dx is going to be equals to, I can take out a 7x to the fourth plus 2 raised to the
bracket,
raised to the fifth power.
fifth power, yeah.
And then now 6 is a factor of 54. So I can also take out 6x.
No, a 54 that are 504.
504. I said that to see if you're paying attention. Thank you, Papa. 504. So that is going to leave
Yes, sir.
84. So I'm going to be 84 x to the fourth. 6 times 84 is 504. X to the fourth times x to the first is x to the fifth. All right, go to plus
2.
no man.
Sir, one key document. We can't take a little screen something. Yeah.
I got cut off a while ago because the document just refused to open. It honestly refused to open. I don't know if I pick up some virus on it. So I just want to finish this question and then I'm gonna see if I can move on. I just this question is not in the document, because I just wrote this one out of my head a while ago.
Okay.
All right, so let's go. So this is going to be now
6x.
very good. dy by dx is going to be equals to 6x.
Bracket.
I come into sound. 6x bracket.
7x. So what? I think I do
Four.
third or
No man, the
fourth.
fourth. Right. I just writing back everything there. And then now let me just do a little quick calculation inside here, sir. So this will become
Cancel that.
No, it can't cancel, no.
Can't cancel, you have to add.
You have to add. Very good.
84 plus 7x.
That's a 91 down.
Yeah, 91x.
91.
X to the fourth plus
X to the
2.
fourth
Right,
power.
plus 2.
Plus 2, right.
Right.
So this will come now 91 x to the fourth plus 2, and that's going to be the answer.
But you know why I say cancel, sir? What I mean by cancel? Because we don't say x to the 4, we don't got that so easy. Yesterday, so we'll say 84 and the 7x.
Okay, all right. So yeah, but I just want to speak the correct jargon though. If you understand it, all it is that you're saying, fine, but I want to get the jargon correct. All right.
So hold on, then don't move this yet, sir.
No, man, I'm not going to at all. I won't.
All right, sir.
No, not yet.
All right, cool. No problem. I think my system is really going, because it shouldn't take so long to start up.
So run a virus scan by your thing, man.
I do have but I mean but I'm just saying though, it like seriously, it shouldn't take this long to
For the document for open, that's why I say run a virus scan by your system.
Yeah,
So it's either the document you want to scan or you scan the whole system to see what
the system, yeah. I need, you know what this is saying to me now? I need to go for my backup, my external hard drive now. Because
you know, so that's why I rely heavily on mine.
No man, trust me. I went and I saved and I bought a 1 terabyte.
Yeah, man, is a 5 me having?
5 terabyte?
Yeah, man.
Oh, you're going bigger things on them, man. I have a 1 terabyte and I keep saving, backing up intermittently because of what can happen.
Everything from school depend it, sir.
Trust
When
me.
you're ready, sir.
Alright, cool, no problem. Thanks. I'm just trying to get this thing here. You see, one week, this thing happened to me one time. I say, Emilio, when me I do my thesis, are you know, final piece of paperwork, you know, rocks,
and everything just gone.
everything crash. When me say crash, you know, crash,
Yeah,
and the lecturer was seeing, you know, when you do work and the lecturer, I see, no, I don't need to upgrade this yet. When you do work and you show the lecturer and say, boy, this is what I have so far.
yeah.
The lecturer says, me I do the work, you know.
And then just see everything gone.
And it's gone, and him say, I'm sorry, I have to
Give you
fail
a
you.
zero.
Yeah, I have to fail you, and then go and do it over. I said, like, seriously? And
Yeah, I'll do him say I do
says,
it. Remember saying no submit nothing, say not approve to say submit nothing.
no, but you see, if I said no, I mean, she said you have to do the work, and me can't say no, but I have been marking your work all along. Me not fail you. But this is what I keep saying to students. You know,
hey man, some man hard. That's what I go say.
You know, all right, let me just see if I can unshare. Oh crap! When you some people complain about Excelsior. Trust me. All right, let's go. So let me just review this one here before I switch screen, because really this is not what I'm doing tonight. This is just raw talk. So what we're given is the question y equals 3x squared times 7x plus 4, 7x to the 4th plus 2 raised to the 6th power. Let me just say something here. So this question, these types of, what I'm teaching is on your syllabus, all right? And, you know, using the product rule, the quotient rule, the chain rule, etc., etc. I can't tell you what your exam paper will look like. Sometimes the man them are mischievous and will write a question like this. So it's better me give you these types of questions and, you know, you go and juggle through them and you go into the exam and I don't get them, as opposed to be the other way around, where I don't give them questions here and I go into the exam and see the question and I don't know where to go. All right. Now, just what you need to do is, I know some of you are finding it difficult.
Sir, can I tell you where I'm lost?
Where?
Where you have this red star, just above the red writing, how you get the 84x to the 4th, that is still confusing to me. Everything is up to this point, that line, that where you have the square
84?
brackets, that is confusing to me because I look at it,
There?
there's 6x outside. All right, above it, there is 6x and there's 7x
All right,
to
hold
the
on.
4th.
Let me just go through from top. So what I'm saying to you students is that I'm going to go through the question from top. Sometimes the examiners are mischievous and they will put questions like these on the paper. So I want you, as I go through the paper, no, rubbish not paper, but the question down, I want you to be able to follow. So if it means that I have to go through it 2 times, I have no problem. But I don't want, while I'm going through, you guys are writing. I want you to be watching the screen and seeing what it is that I'm doing.
Sorry, is it possible after you explain, we can try next one because I may not get it.
I have no problem. I have no problem, but I have my stationary point to go through again, and I'm not spending the whole class on this. This is just a warm up, but I have no problem. Let's go. So remember now, I don't want anybody to be writing. I want you to just pay attention here. I'll give you time to write. So the question says, y is equal to 3x squared times 7x plus 4, rubbish, 7x to the 4th plus 2, all raised to the 6th power. All raised to the 6th power. And we are required to find dy by dx.
And that means the product rules are just questioning.
It is a product rule. Why is it a product rule again? Because you are multiplying. Do you see where you are multiplying? You are multiplying 3x squared. 3x squared is the first term. You're multiplying 3x squared by this here, which is 7x to the 4th plus 2 raised to the 6th power. So there are 2 things. Now, as I was saying to you last week this time, if the question had been 7x to the fourth plus 2 all squares instead of all raised to the 6th power, you can go ahead and, you could have expanded, but why go and expand when there's a power rule? Why expand when there's a power rule? Because you go and expand and you expand and expand incorrectly, as opposed to understanding the power rule and using it correctly to pick up your full marks. Let me stop and say again, based on the pandemic, what the structure of the exam is different. I'm not sure. Yes, I think you guys would have done the pandemic pre-calculus exam, so you'll know how the construct is. But let me just remind you, since most of you didn't go in a math course last semester, so instead of giving your students 4 questions, 4 questions to answer any 3, and each question live. Instead of giving 3 questions to answer any 2, 3 questions to answer any 2 at 30 marks each, what the man them start doing now is on a wholesale basis is to give 3 questions for the online exam, and it's 3 compulsory questions, right? And you know what compulsory means. Everything must be done. So you don't have a choice. So it makes that a little bit more difficult. You would have seen that I sent you the timetable. What was pointed out to me by another group, my BSc students, they said to me that, sir, we recognize that all of the exam they know are 3 hours, we're not getting a 24-hour exam again, right? And partly, my response to that is maybe because of the heavy collaboration. CCCJ said, if 3 hours, boom, done, all right? But look at this. You're getting 3 questions. Each, I would suspect, valuing 20 marks to make it 60 marks of the essay type question and then 20 multiple choice question. Your papers are marked out of 80. Your math papers are marked out of 80. The man then can give a question like this. About 7, 8, 9, or 10 marks. And then if them give this about 10 marks, them can give you a quotient one to another 10 marks and call that BAM question 1. If you get a question like this to 10 marks and it's compulsory, you cannot say next. You must do it. So work with me now. You know the product rule says the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. One more time. The first times the differentiation of the second plus the second times the differentiation of the first. Now, what is important, even to this very day, I have to do it. I know what I'm writing now what I'm calling the first, and I'm writing now what I'm calling the second. I'm writing now what I'm calling the first, and I'm writing now what I'm calling the second. Very important that I write down what I call the first, and I write down what I call the second. I write down what I call the first, and I write down what I call the second. All right. Go ahead.
So the first differentiate by the second, and this
plus the second, Marie, differentiated by the first. Yeah, man, and that's the rule.
Sir, could you repeat it one more time, please? The
So
first.
the first times the differentiation of the second plus the second times the differentiation of the first is the first times the differentiation of the second plus the second times the differentiation of the first. Say it for me, Marie.
the first times the differentiation of the second. The first times the differentiation of the second plus the second times the differentiation of the first.
Very good. Always remember that, you're good to go. The first times the differentiation of the second plus the second times the differentiation of the first. All right, good. So we are now at this line. But allow me to go back to the first line. Remember, you're not supposed to be writing. Pay attention first and you write after. So you notice in red, I wrote what it is that I'm calling my first and then what it is that I'm calling my second. It's very important. because you don't want to get confused which one they call the first, which one they call the second. Matter of fact, JD asked a question, sir, can you give us another one? The other one that I'm giving is not going to be a product. It's going to be a quotient. It's going to be a quotient. All right? What must happen, guys, is that you must remember the rules. So while you're doing the question, you say the story. The first times the differentiation of the second plus the second times the differentiation of the first.
Yes.
So now that we reach this line, and we are saying, let me just go back through that line here. The first, you see, I write it back, 3x squared times the differentiation of the second. This 6 will come in front of here, so then I'm going to write back all of that. And then this is going to be 6 minus 1 to give me 5. And then I'm going to differentiate now what is inside the brackets. The differential of a constant is equal to
0.
0. So therefore, very good. So therefore, I'm going to differentiate this one now because the differential of plus 2 is 0. So I just have this one to differentiate. And the differential of 7x to the 4. Remember, I'm taking this 4 and I'm multiplying it by the 7 to give me this 28. And I'm reducing this by 1 to give me 3. So that is the first times the differential of the second.
Okay.
See the plus sign here now? Plus the second. So what does the second look like? The second is 7x to the 4th plus 2, all raised to the 6th power, see that so? Plus the second, now write it back, times the differentiation of the first. When I differentiate the first, what do I get?
6.
No, you keep saying
6x.
6x, Tashana.
Sorry.
So you can get 6x, and that's my differential of the second, 6x. So technically, your differentiation ends in that line. What is left is for us to do a little bit of algebra. Fix up the something, you cook the food, nice. Yes, please.
Why minus the powers and get the 3?
That's a rule of differentiation. Y is equals to x to the n, dy by dx is equals to n x to the n minus 1. So that's the rule of the differentiation. Y is equals to x to the n. You're going to take the n just as I'm showing you here. You're taking the n here, 2, to multiply by that 3 to give me 6. And then I'm subtracting 1 from the power. You always subtract 1 from the power. You're reducing it. And that is 2, so that will be 6x to the first, which is the same thing as just x. All right, so you always reduce it. So when you're differentiating, you always reduce your power. Always, remember that. Always reduce your power. All right? So the food cooked nice, you have to go share it out now and plate it nice so it is that you can enjoy the food, because them say you start eating with your eyes. Watch me now. So this is us eating with our eyes. We're fixing it up. Them little dot here don't mean full stop. It means multiplication. Big school, we use them dot here for multiplication. So what I'm doing is multiplying 3, multiplied by 6, 18, multiplied by 28, gives me 504.
Oh.
So repeat that.
3 times 6 times 28 gives 504. Check that for me. Check it on the calculator. When you check it on the calculator and you get it, let me know and I can move on.
Yes, sir.
Then the powers now is going to be the 2 from the 3x and the 3 from the 28x. No. Again.
3, 6, 28.
Yes.
I'm waiting for somebody to say yes, sir. You can move. I see.
Oh, yes, sir.
Sir,
yeah.
to the 5th power now, sir. I know my head kind of tough where this is concerned. But you have the 504, which is correct. 504x. X to the 5th power. How does that come in? Because the 3x to the 2nd power is here. You have 6 by itself, and then you have 28x to the 3rd power. So that is where you add the 2 and the 3, you get the 5 to the 5th power, right? That's it?
So thanks for asking. X to the 2nd power times x to the 3rd power. When I'm multiplying and the bases are the same, I add my powers 2 plus 3
Add them.
gives me 5.
5, okay.
So
just for clarity.
when I'm multiplying and the bases are the same, I'm going to add my powers. When I'm multiplying and the bases are the same, I'm adding my powers. Always remember, when I'm multiplying and the bases are the same, I'm adding my powers.
Learn that
Always
in
remember.
pre-cal, sir.
Absolutely.
And I totally forgot.
Absolutely. It were there in pre-calculus. All right, let's go now.
Yeah. Okay.
So what it is that I'm doing, this is a part I believe you guys are having a challenge with, Don't you, so the part yourself. All right, watch me.
Yes, sir.
I am looking to see there are two terms in this. The first term is 504x to the fifth times 7x to the fourth plus 2 to the fifth power, and that term. So the terms one. The terms are separated by addition sign and subtraction signs. You should know this. Terms are separated by addition signs and subtraction signs. The terms are not separated by multiplication sign or division signs. So you know that you have two terms here. So how you know? Because there's a plus sign in the middle. And to the left of the plus sign, you have 504x to the fifth times 7x to the fourth plus 2 raised to the fifth power. That's one term. And to the right of the plus sign, we have 6x times 7x to the fourth plus 2 all raised to the sixth power. So you have two terms. Me I look in the two term then to see what is common to the two of them so we can factor it out. Now remember, the 7x to the fourth plus 2 here
It's common.
is common to both, but one is to the fifth and one is to the sixth. You always remove which one of the two?
The smallest.
The lower of the two.
The lowest
All
number.
right? Right. So you're going to remove the smaller of the two or the lower of the two, and that's why this is to the fifth and this is to the sixth. Me can't factor out 6 out of 5. Me not have 6 of 5 I have, so me can only view the 5 I have. All right? So that's why I have this 7x to the fourth raised to the fifth power, because I always, by rule, take out the smaller of the two. All right? Now,
so when you take that out, that is what you're gonna use in the other section, right, sir?
Yes, ma'am. Yes, ma'am. Yes. Same way, sir. Me know you get it, I know you're getting it. I know most of you are getting it now, by now. But my only challenge
sir. Is just
my
this part
challenge.
what it is right now.
Tell me my challenge that I have, Tashana. I know I'm not getting it now, but tell me the challenge that I have.
We're moving too slow and trying
Absolutely.
to I heard it the first time, sir. One of these nights, me not go sleep, me go stay up and do everything I can.
Absolutely.
That's how it's going to work.
So I'm not. I can tell you, honestly speaking, I'm not concerned that you guys are not getting it. Last class, Ricky just a show up on all of
blaze everything, just blaze it.
Yeah, man. I know I'm only catching it, but my challenge is I don't think you guys are putting in enough work, so it is that you can master it. And you see, this is now 2 minutes past 6. It's at 2 minutes past 6. We have less than an hour left, and I don't get into this. I don't get back into the stationary points. But let us see what will happen. Okay, so watch me now. Watch me now. So I'm taking out the small of the two, so which is that. But if you look here, this is 6x and this is 504x. I checked and I recognize that 6 is a factor of 504. All right? So it means that I can take out all of the 6 and I can take out all of the x, because this is x to the fifth and this is x to the first. So the rule is we take out the smaller of the two. See, so the x to the first. But sir, me not in the first there. So x to the first is the same thing as, x to the first is the same thing as x. That's another log indices. All right? A to the first is equals to a. And a to the 0 is equals to 1. Those are the first two laws we normally present to students.
When did that, sir?
Come on. Watch me now. I'm taking out the 6 because the 6 is lower. I can't take out the 504, so I'm going to take out the 6. So technically, I would have gone through both terms to see what are common. And I would have factored it out here to get me 6x times 7x plus 7x to the fourth plus 2 raised to the fifth power. Then now, I need to twerk it in such a way that me get back what I have up here, so because every line must relate to the line before, but I'm only simplifying it. Watch me. What do I multiply by 6 to give me 504? It has to be 84, because 84 times 6 gives me 504. What do I multiply by x to give me x to the fifth? It has to be x to the fourth. So when I multiply technically now 6x by 84x to the fourth, I get back my 504. Check that for me. I want to stop.
I see it. I used a calculator a while ago, and I
yes,
I got it, sir.
Very good. But guess what now? Guess what now? We want to risk only check it, because I want to check it.
504 divided by 6 gives us 84.
Absolutely. All right. So let's go now. And then now, so when you multiply all of what is outside here, so by the 84, you're going to get 504x to the 5th. And I say the 7x to the 4th plus 2 to the 5th, see it right here, so. All right? Then we again come to the second term now. But sir, there's a 1 right, it's where you see the spotlight? There's a 1 inside here, but it's a magical 1. And that 1 times 6x gives me the 6x. And the 7x to the 4th plus 2 raised to the 5th power times 7x plus 4 to the 2 raised to the 1st power is going to give me 7x plus 4 to the 2. 7x plus 7x to the 4th plus 2 raised to the 6th power. When I'm multiplying and the bases are the same, I'm adding my powers. 5 plus this imaginary 1 gives me that 6. So this now is my simplified version. Now I just have to go work out that. I have to go just work out now the 84x to the 4th plus 7x to the 4th plus 2. And when we work that out, now we recognize the boy, you know, say the 7x to the 4th business can be grouped together, you know, sir, and get me 84 plus 7, not going to be 91, 87, 80, 90.
Because the powers are the same.
The powers are the same, so I can go ahead and add it. Powers are the same. Powers are the same. And then now, I'm going to have my plus 2. And yeah, and that's the answer. And that's the answer, really, the answer. Question. Ask me the question now. Please.
Sir, just one thing, please. The 28, you can just remind me how we get that 28 up top?
The pleasure is mine. Watch this story.
7 times.
And listen. 4 times 7 is equal to 28. I will always subtract 1 from the power. All right, do me a favor. Do me a favor. Do me a favor. I'm going to stop sharing this screen. I'm going to stop sharing this screen. And I'm going to come over to my other screen. All right, so while I was talking to you just now, all right, so yeah, yes, I'll do this guy later from our computer. All right, so while I was talking to you just now, I was actually typing the question, the said question. It is now easier for me to scroll based on the questions that are being asked. It is now easier for me to scroll. Let me just scroll up and show you something. Even though I gave you in the I sent off this document in class on Tuesday, so everybody has a copy of this document. See it here now.
Sir.
I was looking at it, you know, sir, and trying to compare the two, trying to work them out, sir.
Sir?
Yes, Emilio.
Take time scrolling, because I know why the document frees up.
Talk truth. Thank you, Papa. Thank you. No, thank you. You're right. And what I should be doing, I should be saving as I go along. So that means
yes, please.
Yeah.
Do something save.
Thank you, Papa. Thanks for the reminder. See here
Yes,
now, Bogle, I think you were the one who asked the question. The chain rule says y is equals to x to the n. So therefore, this n is going to come in front of my x. See it right here, so? And then I'm going to subtract 1 from the power. So this is a rule for differentiation. When I'm talking, see here, rules of differentiation. So when I'm differentiating, y is equal to x to the n. Therefore, dy by dx. Sir, what is dy by dx? It is a rate of change of y with respect to x. It is a rise over the run. It's a rate of change of one variable compared to the next variable. All right? So you have x to the n. So when you're differentiating, if you can put the x in front of it as a coefficient, the power becomes the coefficient now. The power becomes the coefficient. And then you're reducing the power by 1. Let me write that narrative. Note. C-O-W, the power B-E-C-O-M, the power becomes the coefficient C-O-E-F-F-I-C-I-E-N-T, and the power is R-E-D-U-C-E reduced by 1. All right, just remember that. So the power now becomes the coefficient. Sir, when you mean by that, see, remember coefficient is a number in front of, don't it? Say yes.
Yes, sir.
Yeah, man, good.
Yes,
So
sir.
this is x to the n. So the n now will come in front. So the n now becomes the coefficient. And then now the power I'm going to reduce by 1. Right? So the power now, this is n. So you can put n minus 1. So just note, the power becomes the coefficient. and the power is reduced by 1, right? It's all about the power. It becomes a coefficient, and then it is reduced by 1. All right. So let me just take my time and go all the way down to this thingy bob down here. And when I reach down this, I need to press Control S for what I just typed a while ago. I think it was at question 17. Right.
Yeah, man, that's all.
Good. So, so what happens now, and this is my final time going through this question, and I like having it in the document as Emilio is agreeing with me because if I can scroll through and show you some stuff, right? Also, and I mean, I also like to write because, you know, sometimes you can see clarity when I write. So it's the first times the differentiation of the second. The first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. I don't know if it's Tashana or me, which one talk faster, so let me say that in slow motion.
I heard it.
The first
Times
times
the
the
differentiation of the
differentiation of the second
plus
plus the second
the second times the differentiation of
times
the
the
first.
differentiation of the first. All right, let's go. This is the last time. So here goes. Let me use my spotlight also so you can see what is happening. So here goes. The first. You see when I call the first, may I write it back down. So in a class and teacher say, Emilio, present, sir. Okay. The first, present, you write it back. Times the differentiation of the second. Now you get into differentiation mode. You look at this here and recognize it's a power rule. Sir, how you know that? Because the power is written to more than 1. So once the power greater than 1, you know, so you have to talk about the power rule. All right. So what happens? This goes in front of here, so see it right here, so you reduce this by
minus
1.
1.
Good.
Mm-hmm.
And you write back all of this right in your so, and then you differentiate inside here. Remember, you must differentiate what is inside the parentheses. A lot of students, even at calculus 2,
Forget to do that, yeah.
they forget to differentiate the inside of the something. You got
And then everything goes to hell after that.
Absolutely. Right? Let me tell you when you kind of have an idea when it is that you know you're wrong. When you reach on the bottom part and there's nothing to factorize. So when you're not seeing anything common to factorize, you know there's something gone wrong. Yeah, man. Let's go. And then now we're differentiating on the inside. So Bog, look at this again. When I differentiate here, it's going to be this in front becomes a coefficient. But sir, you're going to just box out the 7? No. You're going to multiply this 4 by this 7 to give me 28. And then reducing the power by 1. So it's going to be 28x to the third. It done right there, you know. So this is a 3-point step. Bam, bam, 6. You write back this, you reduce it by 1, 5. Then you go inside here, so, and differentiate it to get 20. It done. Plus the second. See? The second, everything in the second I'm writing back. Every single thing in the second. Look, see here? 7x to the 4th plus 2 raised to the 6th power. 7x plus 4 to the plus 7x to the 4th plus 2 raised to the 6th power. I'm writing back everything in the second because when I say Emilio, present, sir,
it goes back
I write back.
The rule, sir. It goes back to the rule.
Absolutely. Plus the second, now it is, I'm going to times it by the differentiation of the first. And I'm now differentiating the first. When I differentiate the first, differential of 3x squared is the same thing. 2 times 3 is 6. And I'm reducing this by 1. So you're going to become 6x. And that's 6x. It. Now the differentiation ends in this line. This line here, the differentiation ends. If the question carries 10 marks, this line alone can give you enough marks out of the 10. But guess what? The question will also have other marks or other steps because the question will say simplify your answer. And if it don't even say simplify your answer, you're expected to simplify your answer at this level. Right? Watch me. So I'm
put the steps then, but you don't necessarily need that. Go on. Do you think?
Right. So you're going to know rearrange. So why you're rearranging? Because you have to make it look nice, okay? So watch me how I rearrange. 3 times 6
times 6 times 28 gives you 504. X to the 5th power because you add the 2 and the 3.
Good job, and I get that. And then all of this inside here, so I write back right here, so. And then a 6x, and now we don't want it at the back, we want it at the front. So we put it at the front, and we get that. So we get all of it, Perjam and Emilio. So we get all of this right here.
That's why I'm laughing, sir, because I know Emilio was going to say something.
Right? Right here, so. We simplify it a little bit. Note, always factorize the lower of the 2.
Lower of the 2.
always factorize the lower of the two. Sir, what do you mean the lower of the two? When you factorize them, something like the one year are the same thing like the 1 year. Member said this are the fifth one, so the 1 year go take out. They can't take out the 1 year. When you look on the one the bigger. When you look on the x to the fifth and the x, you know, so you have to take out the x. You can't take out the x to the fifth because the x is lower than the big and the other one. That's 6 and you can't factor out 5 or 4. And the 6 you have to go factor. All right, so watch me. Just as how I said, as so we are doing. So when you look on something, you can take out 6x. You take out the 6x, hold on. You take out the 6x right here, so. And when you take out the 6x, because the 6x is now common to both. So how you know 6x is a factor of 6x, and 6x is also a factor of 504. So how you know that? 504 divided by that, very good. And when you get 84x to the fourth.
84x.
How you know that, sir? 84x to the fourth times 6x gives me 504x to the fifth. Sir, how you know that? 6 times 84 is 504.
104.
And x to the first times x to the
plus
fifth
four
to the
give
fourth,
5.
x to the fifth. Very good. And then this piece here now, the piece here now, I'm going to write it back. So I have found what is common between these two terms. I have found what is common between these two terms. And when I find out what is common between those two terms, I'm going to see now what is left. I now need to see what is left. So in checking to see what is left, I'm going to say, what do I multiply by 6x to give me 504x to the fifth? The answer is 84x to the fourth. So how you get that? The piece here, the 504x to the fifth divided by 6x, I'm going to give me 84x to the fourth. So then all you know, so you're right. Multiply 84 by 6, and you get back the 504. And multiply the x by the x to the fourth, and you get x to the fifth. And the 7x to the fourth plus 2 to the fifth are the same 7x plus 4 to the fifth, so you don't need to write it back. All right? And then now you put back the plus sign because you're done the piece here. You put back the plus sign. Then you look now to say, what do I multiply by 6x to give me 6x? So no 1. Good. That's why you have this 1 imaginary door in front of yourself. And then you can say, sir, what do I multiply by 7x to the fourth plus 2 raised to the fifth power to give me 7x plus 4? 7x to the fourth plus 2 raised to the sixth power. Also, we need one more of it, or you know. So because the 1 is 5, and you're going to need one more in order to make it up to 6. Very good. And that's when I have all of this right here, so raised to the first power, right? When you multiply, and the bases are the same, you add the powers. So when you multiply the 1 year to the first times the 1 year to the fifth, you're going to get back the same 1 year, but it's going to raise to the 6. See yourself? The same 1 year raised to the 6. So you're going to another step. And then now, in another little square bracket, you know, we can fix up. It's about, sir, this raised to the first power, so you don't have to have the parentheses. No, you don't have to. So, oh, sir, I see what we can do now then. We not can add the 84x to the fourth plus 7x to the fourth? Yes, to give me, see it, sir, right here, sir. But, sir, why can I do that? I can only do that because this is raised to the first power. I can only do that because this is, if this were raised to the second power, I'd have to go work out that and square it. But because it's raised to the first power, I can drop the parentheses. This is why I'm saying to you that the power rule only works when the power is greater than 1. If the power is 1, you're not talking about the power rule. But if the power is greater than 1, then you talk about the power rule. So we say 84 plus 7 is going to give me 91. X to the fourth plus 2, the 2 stands alone. And then we just write back all of that little something. The little story, I'm going to write it back right here. So question done. You can't go any further. Question done. You present your work like this, you get full marks. No question asked. Full marks. All right.
Write that.
You want to write it?
Thank you for going over it painstakingly. Thank you, sir. I appreciate it.
No problem. Might I just, while you write off, I'll wait patiently. But while you write off.
No, sir, I'm screenshotting this, sir, because I have it written down from what we did before. This that we're doing, this question that we're doing by hand is this one that you have on the screen, and I didn't realize it. So I'm screenshotting it just to see.
Right.
Scroll
down.
The way you, Emilia, you want to get the whole question?
Look like you have got small it up.
Yeah, man. I got small it up. One more. No, me not small up nothing. After me no use computer now. Watch this. Bam! Look on that.
Split the screen.
Yeah, man. I say a 17 with the down, question 17. Yeah. See that? You have the whole of that now. All right, let me just say this. This piece here, so.
No, not necessary. This good.
Yeah, man. Let me just tell you something right here. So, you see, if you come class and follow me and show you, there is
Can't go
no
wrong.
way you can go wrong. Me nah
All right, I
ask
tell you
you.
what happened, sir. You see, in the last class when I had to leave, like I had to run and go sort out something. Sort. When I came back, I was totally lost, and I was saying I'd have to go on YouTube. I said, don't do that. So I'm gonna follow your instruction. I'm not going on YouTube. Just work with what you teach us.
Yeah, man.
Because, yeah,
Yeah,
you miss a
true.
little, you miss a lot, and that was my problem, sir.
Yeah, man. Very good, very good. Jen, I saw that, and I'm happy. So hear me now. So I saw your message, Jen. I hear you, Tashana. Hear what my request of you now. You see, because I'm using quite a bit of this time to go through so it is that you can fully understand.
Mm-hmm.
At the back end, it's going to come and bite me because I'm not going to be able to finish. So you see, when I call one class and I say, hey, I'm going to come meet me on one Saturday evening or one Sunday evening or one other evening.
I'll be
You
there,
know,
sir.
me no want nobody comes say,
Sir,
sir, I can't do it.
No, I'll be
why?
there. I'll be there, sir. I need
Well,
it.
me
Yes,
have something
sir.
to say about this, sir. I
Yeah.
repeatedly saying that
Mm-hmm.
due to the fact that some of the students, like myself, is
Mm-hmm.
unable to grasp the math are in one or two go, we
Mm-hmm.
have to suffer the consequences in giving up a weekend like a Friday, a Saturday or a Sunday.
Mm-hmm.
No, I say that because it is impossible to
Mm-hmm.
try to learn a math in one or two go, especially
Mm-hmm.
when you're not so comfortable in the area
Mm-hmm.
and that it's not something you're used to in a
Mm-hmm.
day-to-day life. Even though
Mm-hmm.
them say math is a day-to-day thing.
Mm-hmm.
No, they put this business calculus, which is a tedious topic, in
Mm-hmm.
a 10-week span,
Messed up. Mm-hmm.
right? With causing the student to try to cramp. But lo
Mm-hmm.
and behold, we can't cramp it. To truth, sir, we can't cramp
So,
everything.
so you're
So
supporting.
we are
You're
going to, you should
Go ahead.
The
specify.
sacrifices are there. That's your thing.
Okay. So you're
Yeah, but
supporting the point that I'm
there's
making.
so many sacrifice. How many sacrifice we are going? Sorry, how many sacrifice we are going to make? How much courses we are doing today this week? I think it's 3 or so. How many sacrifice we should make, sir? We can do so much and so more, and so much and no more.
No
Sorry,
more.
Mhm.
we
Yeah.
can't manage it, sir. Me not
Um.
gonna lie. And
Okay.
everybody is expecting the same sacrifice. How much sacrifice can I give?
Yeah. I
How
hear
much?
you. I hear you. But guess what? Um. And forgive me for how this may sound, but I absolutely mean nothing by it. So many others have done it, JJ. You too can do it. But sir, may I have this and that and that. I have students in my class who were single parents, and then in another class, and the baby had cried. Go sit down. I said, don't talk to the child like that. I said, don't you ever dare talk to the child like that in my presence. But sir, you might give it to. I said, I don't care. If needs be, put the child to sleep first before class. But no, if you want to get up and go feed the pitney, go and go feed the pitney. But don't talk to the pitney like that. And I'm going to tell you, I've had students in the same summer semester of the 10 weeks have done it and have done it well. I know everybody's circumstances are different.
Mine is dire, sir. So I hear the frustration in Janelle's voice, and I agree with how upsetting it is. But we have to make do with it anyway. We take it. I
Sir, that's why.
cannot afford to reset this. So if I have to
If
go
all
to my way
boys
and
love
not
the
sleep,
choice, now we don't have
trust
none.
me, I already give up so much sleep. We don't have no
All
time to
right,
sleep.
sir, moving on, because time ago.
Time is
So,
going.
yeah,
But
let's
Marie, you're coming in, honey. Let me hear what you say, Marie.
That is why, sir, because we have to be cramming these things in our brains, especially for me who don't know nothing about math. You see, as soon as we're done, because we just cram it, forget to pass. Sir, when you finish, it's like you can't remember whatever it is that you was taught. It just little, like you just go through one year and come through the other, just to pass, and then you don't remember. That's not good for us.
you know, the major problem, sir, is that the
Mm-hmm.
fact that them give it pre-cal and then those make up go to business cal right after. So the info would
Yeah.
have fresh in our brain.
And
The
Yeah.
pre-cal, let's say we are last year. And
if
then I come to
only if
business cal
only
now.
one of you had reached out to me to say that this was happening, I would have corrected that. but maybe you
Yeah.
didn't even know that you're supposed to do another course. But anyhow,
So that's what I tell you. We did here, so we have the business calendar, sir. But here we are going. We assumed it would have come come the next semester after. But when we say the next timetable and worse, the rush that was on to get the timetable together so we can start. Nobody remember nothing.
True.
That's our
All right.
problem.
All right, here what I'm going to move on, but I'm just going to say to you, I hear the frustration. I hear the frustration. I hear the concerns you're having. As I said to your students, it's not my first year teaching business calculus in the summer. This is countless times I've taught business calculus in the summer. And the students were not just doing business calculus alone in the summer, they were carrying a full summer load. I know each student's circumstance is different, but all I'm going to ask of you is to persevere. You guys are at the tail end of it. You're going to feel pressure. Yeah, man. You see, if you're at the tail end of your course of study and you feel like everything I'll go through, something's not happening. And I'm going to say at the tail end of it, you're going to feel this way. All right, let's go. All right, so that
Sir,
is that.
before you say let's go, sir, you mentioned that if anytime you call a class outside of class, I'm saying to you, I know it's difficult and it's rough and it sounds kind of callous to everybody else who's suffering because I'm suffering too. I am willing to join that class. Just let me know when.
Absolutely, and I won't tell you. I won't tell you. And I won't tell you. Got you. So what I won't do is to tell you. I won't tell you today that we're having a class tomorrow. I'll give you ample notice, right? Because I am going through, and I am trying to be very creative here. And to be honest with you, it's under pressure.
You're under pressure, sir, because you're part of the head of the school.
Not only that, I am under pressure because I have a mandate to fulfill. Try as I may and the difficulties as it may be, me I forget only to understand, I want to learn something. So I have a mammoth task myself. All right, let's go. I'm going to give you a question on the quotient. What is also encouraging again though, guys, is when I see comments coming into the, messages coming to me to say, sir, thank you. I finally see what is happening right here. So it is encouraging for me. Yeah, man, it's encouraging for me. All right. Now, I'm giving you this one. So given y equals that, comma, I want you to find dy by dx for me now. I want you to find dy by dx for me. Now remember, what rule will we be using for this one?
Quotient rule, sir.
Why?
All right. The first is a divisional thing. It's not just about product rule. You have to divide. So when it's
you're seeing a numerator and a denominator.
Right.
So you know that you have to use a quotient rule. Now hear my story before you start. Story time. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator. None of them all over the denominator squares. I'm going to say it again. None of it.
Sir, repeat that one, please. I'm writing it, please.
No, you don't need to write it. It's in the handout. That's the point I was going to make.
Okay.
It is in the handout.
And I have it open in the background,
Multiple times it's in the handout.
I have it written.
The denominator times the differentiation of the numerator minus the numerator
minus the numerator times
the differential of the denominator
all over the denominator squared.
All right.
I
am going to work this one. I'm going to work this one with you.
I'm reading it with him.
I'm going to work this one with you. What do you want me to do? Do you want me to work this one with you, or do you want to try it on your own? Talk to me.
We're going through that one. We'll just look on.
Work this one with us, sir.
Step by step.
Work it, sir, because I'm kind of on this.
All right, so let me just.
No, man, you don't have to do nothing. No, just run through it step by step like how you have it there, sir.
I know. No. It's a different question that I'm giving you on here. So I'm just copying that answer there, and then
put in
the stuff. Right. All right. So remember now.
Shauna, sorry about that. I'm just saying I was reading it with him. The document, he sent it in the chat, in the WhatsApp group, and I actually sent it to myself. So I was reading while he was talking. So sorry.
This is question, we're reading now question 18, question 17, question 18. So let me just put that there, put that there, put that there, put there, put that, put that, put that, put that, put that, put that, that. All right. So the quotient rule says the denominator times the differential of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. This story, one must know. One must know this story. This story can't do differentiation without you know it. So once upon a time, the denominator times the differential of the numerator minus the numerator times the differential of the denominator all over the denominator squares. Watch me. I don't want anybody to write. I want to go through the question with you, and then I'll give you time to write. I'll give you time to write. Watch me. The denominator is 2 minus 3x squared over 2 minus 3x squared raised to the fourth power.
To the fourth power, yeah.
Right, so it's going to be 2 minus 3x squared raised to the fourth power. So it's a denominator times the differentiation of the numerator. What is the differential of the numerator? What is the differentiation of the numerator? Oopsie, sorry.
3x. Sorry.
3x.
3x to the second power.
Very good. 3x to the second power. All right. So 3x to the second power. All right. So it's the denominator times the and I should show you. I'm actually typing. That's why I said that big black box there. So it's the denominator. The denominator. Matter of fact. Let me show you what it is that I'm doing in it. So it's a denominator, which is all of this here, so times the differentiation of the numerator, and the numerator is 3x rubbish. The numerator was x cubed, so when I differentiate the numerator, I'm going to get 3x squared. All right. So it's the denominator times the differentiation of the numerator minus the numerator. Remember, the numerator was x cubed minus 1. So it's x cubed minus 1. X cubed minus 1 times the differentiation of the denominator. So remember now, the denominator is this. The denominator is this. So we need to differentiate now the denominator. Remember, this is the power rule. The power rule. No, before you do that, before you reach the 6x, remember we have to take that 4 here and multiply down here, so don't it?
Oh, yes.
Yes, sir.
Yeah,
and then
right. So there's going to be 4 up there, so then I'm going to have
4, right.
I'm going to have
the
2,
differential.
The 2 minus 3x squared, don't it?
Yes, sir.
Yeah.
To the third power.
Very good. Raised to the third power. Raised to the third power. And then times now by the differentiation of the inside here. I mean, tell me what it is now.
2, 3, 6, 6x.
And negative 6x, sir.
Thank you very much, JD.
Sorry,
Thank you,
Thank you, Nella. Negative 6x. You see, that's with me, sir. I always forgot the powers. Oh.
Yeah, you see, that's why me silent a while ago, you know, come say me not.
Yeah, sir, just pause and him get silent, you know.
All right, so watch this now.
So I have a team behind me, sir. What do you?
All right, see me, so I realize, you know, all right, so I need to go back to sharing my screen. All right, so let us go through it. Since you weren't seeing the full gamut of it, let me just go through it again. So it says the quotient rule says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. Everything over the denominator squares. Watch me now. The denominator, let me just go to my spotlight. The denominator. Ricky! You don't understand how Ricky now talk to the teacher tonight. Ricky, you all right, Papa?
I'm here, sir. I'm following.
All right, nice. All right, so it's the denominator, 2 minus 3x squared to the 4th. So it's the denominator, bam. All of this is the denominator. The denominator times the differentiation of the numerator. The numerator is x cubed minus 1. The differentiation of negative 1 is 0.
Zero.
Why is that 0? Tell me. It's a
constant.
It's a constant. Very good. It's a constant.
The differentiation of a constant is 0.
Very good. The differentiation of a constant is equal to 0. I hope you guys
It's
are
always
listening
0.
every single time. And then now I'm going to differentiate my x cubed. Now when I differentiate x cubed, I'm going to get this 3 come in front. So I'm going to get 3x minus 1 from the power, so it's 3x squared. See it right there, so? Remember, this little dot means multiply, right? So it's going to be 3x squared. So it's the denominator. See, the denominator, come right here, so, times the differentiation of the numerator. I'm differentiating the numerator. I'm going to get this. Bam. Minus is this. The numerator, see, the numerator is x cubed minus 1. See, so, x cubed minus 1. Times the differential of the denominator. No need for differentiate the denominator. Oh, sir, I want power again, power rule again. Yeah, the 4 you come in front of this. See that so? Then I go right back this and reduce it by 1. 2 minus 3x squared to the third. 2 minus 3x squared to the third. But I know how to
You get
differentiate
the
inside
negative
here,
6x.
so, and I suck on me get the negative 6x.
6x.
All over the denominator squares. Watch this now. 2 minus
squared.
3x squared to the fourth, all squares.
Mm-hmm.
Right? Let me just fix up something right about here, so, because the I don't like how something looks so. All right, I prefer that way then. So now, bam, I have that. Now I need to kind of fix up that. So I'm just going to copy this now and paste it down here. So paste. So I can just fix up the piece here. So you can look at that screen. I mean, the things I have right there. So now,
Sir,
yes, please.
sir, is
Yes,
it that we
ma'am.
still have to differentiate still, right?
No, man, no.
So that four would
Differentiation
go in
finish.
front.
Differentiation finish.
Finish. Okay.
Yeah, man, differentiation. All me doing is just fixing up
Okay.
right about
Just
now.
to rearrange it.
I just
Simplify or rearrange.
rearranging.
Which one, sir?
I'm rearranging right here, so.
Rearrange it.
So if you look right here, so watch me now. Remember now, this minus is separating this term from this term. So I'm gonna have the 3x squared in front of this, and then the minus sign I'm gonna stay right here, so, and then I'm gonna multiply the 1 here by the 4. This minus 1 times 4 is minus 4 times a negative 6x. So I'm gonna have a positive 6 4 is 24x. Everybody see the 24x? Talk to me, somebody, anybody.
Sir.
Yes, sir, I'm seeing it.
Sir.
Yes, please.
Sir. I see that part, but what about the 3x? We see that dot 3x squared. That don't get multiplied as well?
See, come on. This 3x squared gone in front of this, you know. See down here?
Yeah.
Yeah. It's gone in front of that.
Oh,
so now we
okay,
we have all of this now, right here, so. And then this negative 1 multiplied by 4 is negative 4. And negative 4 multiplied by a negative 6x is positive 24x.
Gives you a positive.
Right. And then this x cubed minus 1 will come back right here, so. And this 2 minus 3x squared to the third come back right here, so. But you have to remember though, why is it? Go ahead, Papa.
This took away for a second. I apologize. Yeah. So give me back down at the end part. No, not this one. Get this.
I know. I'm just putting the 1 right there. So I'm saying to you that there's a negative 1 right here. There's a 1 in front of this x cubed minus 1. So that negative 1 times the 4 is a negative 4. And negative 4 times negative 6. Yeah.
Sure. You usually highlight that magical one a different color so as to not confuse the whole issue.
True.
So we get it, sir. I get it.
True. Right. So this negative 1 times this 4 is a negative 4, and the negative 4 times a negative 6x. When I multiply two negative numbers, I get a positive. So that's why I get a positive 24x. So you have to be very mindful of that. And then, of course, I still have to write back my x cubed minus 1, and I have to write back my 2 minus 3x squared to the third power. So I'm coming down very nicely. But I want you to watch that trick here.
All right. Hold on. Go back up, sir. That's what I tell you. I miss from the starting of the actual.
No, so that's at the start of something, you know.
No, that one. The second row, the second line. Yeah, that one. This area I go through, but me never get from the beginning of it. From the 3x.
The denominator. Watch it. See, is the denominator. The denominator times the differentiation of the numerator. And we differentiate the numerator, which is going to give
No, man, you give me, sir.
Yeah, so you were here for that.
Not that one we highlight, you know. The second, that one, you know.
Yeah, but we just looked at that a while ago. I just go through. No, but you're right. But I'm just saying to you, a while ago just agree with me that it's a positive 24x. So you were here a while ago.
I talk about me come catch a part there, so me can tell you that part there. But I talk about from the 3x squared, yeah, put back everything, me don't know nothing about I need to all of that.
All right, then watch this.
So start, that's why I beg you start over back
This 3x squared right here, so
yes, sir.
I am just putting it inside it because I'm rearranging. So I just put the 3x in front of here to give me this here, so.
That's why I wonder how you get.
And right, because you I always rearrange to get the.
Two R. Yeah.
Yeah.
Moving on now.
Right. So when I do the rearrangement now, I just put in this 3x squared in front here, so I will get it here, so, and then the 2 minus 3x squared to the 4, I write it back right here, so. Right.
Oh.
And this is just saying that the negative 1 times the 4 times the negative 6x, give me the 24x. And then I write back this, right here, so. I'm going to write back this, right here, so.
Right, so. Oh, okay.
I don't have to reach you now. Don't have to reach now.
Right.
And I want to do a recall. If we can remember to recall myself. Recall, come on. I'm typing it, guys. Let me just put that inside here so that you can see what is happening here. Oh crap. All right, so cancel. And I do that copy. And I do that case. All right, so I want you to recall something here for me. And this is from pre-calculus. And what I want you to recall is a to the m raised to the nth power is going to be equal to the a to the m times n. Right? Which is really a to the mn. Right? A to the mn. So when you have a base raised to a power, raised to another power, just multiply the two powers. Just multiply the two powers. Let me go again. A to the m raised to the nth power is going to be equal to a to the mn. A to the m times n.
So that's a pre-cal.
Right. So you keep in the base. Watch me now.
Those two, 4 2's 8. 4 2's 8.
Very good.
Okay.
Very good. Very good.
2 times 4 times 2.
Very good. That's the point I was trying to just bring across. So you can get the 8. The rest of you, are you seeing that 8? If you're not seeing it, say something, don't wait until afterwards and you wonder where sir get that 8 from. Let me just go through something again. See, there's something here, so 2 minus 3x squared to the 4 raised to the second power. Recall from pre-calculus, a to the m raised to the nth power is going to be equal to a to the m times n. Watch me. 4 times 2 is equal to 8. So I have simplified this thing here so far, but guess what? We still have a little bit more simplification to go. So I'm going to copy that. I'm going to paste it down here, so, and then we'll move on to this. But before I move on to this piece here, do you understand these two lines that I've written so far? What I'm trying to do is to recall what it is that you would be required to know for your
For the breakdown.
right.
Mr.
Right. So I'm just doing it stepwise for you. All right, let's go. So now I am going to be fixing up in this something here. So, all right. So I'm going to be factorizing. Now I want you to pay attention to this line. I want you to pay attention to this line. So my black spot is because I'm typing as we go along, and then I'll project. Now there are 2 terms in the numerator. Sir, Mr. 1, 2, 3, 4, 5, 6. No, this is being multiplied by this is being multiplied by that. The multiplication is not considered a term. So all of this here, look at the spotlight. You see all of this here from the 24x come right down to the 2 minus 3x squared to the third is one term, separated by this plus sign, and all of here so is another term. So I'm looking to see what is common.
Sir.
Go ahead.
Sir, because you have the black box, that thing open, it's delayed. So it's kind of confusing when you're pointing and you move.
All right. Oh,
but
let me reduce it. Let me reduce it. So what I'm saying to you, this 24x times x cubed minus 1 times 2 minus 3x squared to the third power is one term. And then the term in front of the positive sign, which is the 3x squared times 2 minus 3x squared raised to the fourth power is another term. Hear my question to you. Hear my question. What is common here that is common here?
2 in the bracket, 2 minus 3x squared, sir. Those two are common.
And 3x.
That just gonna say 3x, so that me see what is
Yeah, but I'm not only that alone, you know, because
Is it 2
Tashana give me a piece of
But, right, but Tashana gave the second part of it.
You know, but a piece of something Tashana still give me.
So
You don't know?
just finish the piece. So now we have a whole.
You have a whole, okay.
Yes.
Careful now.
Dear Jesus, Emilia,
You say, Emilia need Jesus, you know? Him need Jesus. The full dose of Jesus. Tell me now, please. How much of that something supposed to take out? Remembering that we take out the lower of the two. That's a hint. We take out the lower of the two. Look on this one here, so. And because a while ago when I hear Tashana say it, and then JD come in and say something else, you know, hear the full story, you know.
So, sir, you're going to take out 2 minus 3x squared to the third. That's the one you're going to take out, sir.
Thank you, please. Excellent. And then when we take out that now, what else can I take out?
3x.
Very nice. Excellent. You guys are learning. Excellent, you know. Very good. So 3x times what? Give me 3x squares.
24.
No. 3x times what? Give me 3x squares. Say x now.
X.
3x.
X. Yeah, man. X, man.
X. Oh,
and then no. 3x times
9.
3x times what? Give me 24x.
8.
All right. All right.
3, 8, 24.
Let me just take out this and then show you, because I don't think you guys are following what it is that I'm doing. Oh, my head starts to hurt me again. Jesus, help me. All right, let's look at it now. What I'm saying to you is that the 2 minus 3x squares to the third is common because it is the lower of the two. So that's why I took out the 2x minus 3 to the third. All right? And then now of the 3x squared and the 24x, 3 is lower than the numeral 3 is lower than the numeral 24. So I'm taking out the 3. But of the x squared and the x is lower, so I'm taking out the x. So this is all that I can factor out. Now, what do I multiply by 3x times 2 minus 3x squared to the third to give me 3x squared times all of that? Watch me. Rockstone. I left off something.
I don't want to go back through, but I don't want to go on.
No, man, it's all right, man. Don't worry about it, man. I'll go back through for you. I'll go back through. It's just that I left out something a while ago, and that I just realized. And that's, oh, crap. And then I put in an extra piece of something. Yeah. All right, let's go again. So now that I factored out, let me go right here. Let me go right here.
Is it 3 times 2 times? It is 3 times 2 times 4. Give you the 24. 3 times 2. That's 6 times 4.
No.
Negative 1 times negative 4. Yeah, negative 4.
Right, negative 1 times positive 4. Give a negative 4.
Times positive 4 again, negative 4, and negative 4 times negative 6 give a positive 24x.
Yeah. You see, Marie?
I understand, dear sister. I was trying to see what you get to get the 20, the 8, the.
Oh, okay. All right. That's what I'm gonna go through now. Give me half a second. I'm being very deliberate by taking a pause. I'm not frustrated, so don't think that I'm frustrated as I'm taking a pause. I'm being very deliberate.
No,
I
man,
want
you're
to
frustrated.
I want to just clear your mind a little bit. So I'm pretty much taking a 2-minute screen break. So just breathe for me. Inhale and exhale deeply for about 2 minutes. And I'm doing the same thing too.
Okay, sir.
Hold on, I'm gonna go for some water. Sir.
That is fine too.
Me too.
All right. Okay. All right. Now, so let's go down, guys. So what I'm asking, what is common here that is common here? What is common here that is common here? I'm looking and I'm seeing that the 2x minus 3x squared looks like this 2x minus 3x squared. One of them is raised to the fourth power. The other one is raised to the third power. But sir always said to us that we're going to factor out.
Sir, 2 minutes gone already. I'm just gonna come back with my water.
Don't worry about it, man. I just started a while ago. So this is what I'm just saying. So this is what I'm saying. So I'm going to
Sir,
ask.
excuse me. Sorry to disturb you 1 second.
Go
I'm
ahead.
still at work and I have to leave now to catch
Ve-
curfew hour. So you're going to send this paper as usual, right?
Yes, honey bunches.
All right, thanks.
Cool. I think it's a curfew start back again. All right.
Yeah.
Watch me
Sure.
now. I'm looking to see what is common here. That is common here. What is common here?
The 2 minus 3x squared plus 2. Sorry,
No.
2 minus 3x squared.
To the second, right. So 2 minus 3x squared and 2 minus 3x squared. But one of them is to the fourth power and the other one is to the third. But sir always said to cut the one that is lower.
Factorize the lower, right.
So I'm going to take out the 2 minus 3x squared to the third power. All right? Watch me now. I'm going to look on the other something them now. I recognize I have 3x squared and I have 24x. What is common? Well, let us not look at the 3x. No, let us look at them in pairs. The 3, what is common to the 3 and the 24? So the 3, yeah, no man, what is common to the 3 and the 24? You know that the 3 can go into the 24, so the 3 is lower, so that's why we took out the 3.
Right.
And then we have the x squared and the x. So what it is that what is lower? The x is lower because the x is lower, right. So that. So when you look at it now, you take out the 3x squared. That's just one other way of looking at it. Some other person can look at it and say, sir, 3x is common. So you take out the 3x. No, you take out, there's nothing else that is common. There's nothing else that is common. So you can't take out anything else. So I just going to put back my brackets now and then we'll see what is left. I'm just checking to see what is left. Watch how I do it. What do I multiply by 3x to give me 3x squares?
Another x.
Another x. Watch me. What do I multiply by 2 minus 3x squares to the third to give me 2 minus 3x squares to the first?
Another 2 minus 3x.
Very good. Very good. And that's why I put this in right here. So they may finish the term here, which is all of this on this. You can reach the second part now. What I multiply by 3x to give me 24x? Are the 8? Very good. What do I multiply by 2 minus 3x squared to the third to give me rockstone? 2 minus 3x squared to the third. I need to hear the answer.
So come again. What you multiply by what?
What do I multiply by 2 minus 3x squared to the third to give me 2 minus 3x squared to the third? See?
1.
Very good. So we multiply by 1. So somewhere in between right here says a magical 1, but we now write it. And then we have this x cubed minus 1 left, don't it?
Yes.
So I'm going to write the x cubed minus 1. So when we multiply all of this by this, we get back all of this. All right? Take it in bite-sized pieces. You can eat an elephant, but it's one bite at a time. All right?
Jesus, hold on. Last a while ago again. How you say get the 8?
3x into 24x goes 8 times.
Oh, 8 times. All right.
Right. So now that I have this, I'm just going to fix up what is on the inside right here. So inside here, so I'm going to fix up. Right? So I'm going to copy that. I'm going to paste it in here. And then you have the screen to look at. What is this x times 2? X times 2 gives a what?
X times 2, 2x.
Good. And what is x times negative 3x squared?
Negative 3.
3x to the fourth power.
The third power.
Negative 3x to the third power.
Cube.
Right. Negative 3x cubed.
Same thing to the third power.
No, same difference. Yes. No, somebody said something else, but what you said, Emilio, is correct. Also. Good. And then 8 times x cubed is going to be?
8x cubed.
8x cube.
And 8 times negative 1 is?
8.
Negative 8.
That's a negative 8.
All right. Look on that and tell me if it makes sense. Watch it again. X times 2 is 2x.
For the negative 8.
Negative
Put the
8.
for the negative.
Negative 7. I'm nervous. Me get nervous. You know?
Nervous, sir.
Yeah, because Shelly I run tonight, so say me just get nervous all of a sudden. All right, let's go.
Should I run?
Yeah, they're running tonight. 9:40.
Jesus, please.
X times 2 is 2x.
So, sir, we have your divided attention tonight.
Absolutely, because class will go done soon. X times 2 is 2x. And x times negative 3x squared is negative 3x cubed. Then we finish with that. Put back the plus sign. 8 times x cubed is 8x cubed. And 8 times negative 1 is negative 8. So let's go working us now. Them two you can add together, don't it?
Yes, sir, because the powers are the same.
Very good.
8 and 3, 11.
No, it is a negative 3x, so it's going to be 5.
Negative 3x plus 8.
Sorry. Yes.
So it's going to be 5. It's going to be 5.
Yeah, add it. 5x to the 6.
To the third.
To the 6.
To the third.
To the third, and add the powers.
Powers are the same.
Powers are the same.
Powers are the same. Oh yes, enough.
Powers are the same, so you add the
only when you're multiplying the powers, you add them.
Okay, just remember, yes.
All right, so I'm going to have 5x cubed plus 2x minus 8. But it finished right here, sir? No. You know why? Because this 2x minus 2 minus 3x to the third, 2 minus 3x squared to the third can cancel out with that 2 minus 3x something down here, so.
Yes, it would
all right. 5 in the denominator.
5, yeah, 5, right. I take it out. You take it out of the denominator, left the 5.
So I'm gonna have 5 in the denominator and take out everything up here, so with something up here, so. And then I shouldn't do that. I should have just do this.
And it seems hard, you know, I just because it's long.
It's because it's long. That's the problem. Watch me now. So, I'm feeling led to just do a cancellation here so that you can see what is happening.
Yeah, just to see. Yeah, do it because some people might not over as why you do it. Why that come back to that?
Absolutely.
Sure.
Yes, please.
The 8 we are at the denominator where you have 2 minus 3x squared close bracket to the 8th power. The answer below in red where you move it to the 5th power. How was that made possible?
Oh, you never listen. See, all right. He must do it then.
I was listening, but me on.
We take out the one in the numerator, 2 minus 3x squared to the third. Take it out of that one there, the 5. So literally we just minus the powers and can minus the 3 out of the 5, 3 out of the 8, and left 5.
And I know there's a rule where you divide, you actually subtract the powers. So that was what was done. Okay.
Yeah. So we don't factorize. Sorry, we cancel out.
Thank you, Amelia.
With the correct word, sir. Because I don't want to say cancel out.
But yeah, you're correct. All right, so recall again, a to the m divided by a to the n, you're subtracting it, so it's going to be a to the m minus n. So the law of indices, a to the m divided by a to the n. Once you're dividing
You
on the basis
subtract
that it's
the
same,
powers.
it's going to be
You subtract the powers.
right. So you can subtract the power. So in this case here now,
You see, I remember that, you know, but very good.
right.
Sorry.
So that one we cancel out. That one I don't understand. I'm gonna 5 times.
Oh,
5 of them.
you have
Because
to- you have to-
remember don't you say you know. You say don't you say you have 2 minus 3x squares times 2 minus 3x squares 8 times. Don't.
Yeah.
Yes,
And
sir.
when you take out 3 of them out of there, you got 5 left. Don't it make sense?
Yes,
Yeah,
sir.
man. So this is so what I have right here. So now is my final answer.
Yeah. It long, but it understandable.
And that's why I am going to send out this document so it is that you can look at it. Now it's 6:59. You have a class to run tonight. You have a minute to ask me a question. Are there
I
any
really want to go to
questions?
classes, sir. God knows.
Sir, just don't. The question is, please don't forget to send this
I'm
document
going to
that's
send it. I am
updated. So
sending.
please.
I just click save and
Sir, you have a class right now?
No, I have something to watch. Right?
I have something to go watch right now. And you know I'm
Oh,
not
I
even.
thought you could keep it up for 2 minutes.
No man, guess what? No man, this is Bogle. No man, Bogle. I'm going to even do it better than keeping it for 2 minutes. I am
When it was the
closing
semester
the
again.
document. Say it again, Milo.
When it was the mid semester again.
Don't ask that right now. Don't do that, please.
The mid semester.
I
Okay,
know.
so
I'll keep it in my mind. So
I'm going to tell you. Let me just
all right, so you're ready yet. All right, no worry. No man, that's just yourself. If you're not ready yet, no worry. Make it stay.
Thank you, sir. Do appreciate it, sir.
Next after the holiday. Like you tell me after.
That's
Yeah,
right.
yeah.
Tell us after the holiday.
Week after next.
We have all kind of assignment due, so please. Erica Sop is chiefest among them, so me just want to finish everything.
I am actually.
Remember for boss me Erica off here, sir. We are dealing.
I am actually trying to send this before we go, but 1 minute, please. So I'm sending this here. Do me a favor.
Sir, remember to sort out my queue, please.
My queue.
And Educosoft.
I tell you.
Remember the recording.
Yeah, man. I remember everything. Tell my queue to whenever she has a time to just give me a call, please.
Sure.
Yes, please. All right, give me half a second. Let me just finish this 1 minute, please. I don't want to get distracted and then I know I start it and then don't finish it. All right. Go ahead with the sir now. All right. So this.
Good night. This is Joan.
Hey, Joan. What's up?
Yeah, sir, I'm not in your WhatsApp group.
Oh, who's the admin for the WhatsApp group, please? Can you just drop your information in the?
Yeah. Send a number.
Send a number, please, Joan.
Sir?
Thanks. Drop the number in the chat, Joan.
Okay.
Yeah, thanks. And anybody else here not in the WhatsApp group, please just drop your
number now.
Right away. Please. All right, guys. So I've actually downloaded the document that I just worked on, and it's taking its own little time to load in. All right, do me this favor.
Yes, sir.
I want you to take some time. It's really not difficult to just go through the stuff. Please, I beg of you.
I am going over it, sir. This is the day, sir. I'm telling you. I was at a loss just for 2 minutes. I stepped away last week. I don't want to happen to me one more time. I can't afford it, sir.
Bless you. All right. So if you check your WhatsApp group in, all right. Joan, when you get added to the group, Joan, you can just ask somebody to resend the stuff for you, because I am actually sending it to the WhatsApp group now.
Right away.
I don't want to forget. So now that you see it in the group, confirm that you see.
Thank you, sir. I see it.
Bless you.
Thank you.
We'll talk. All the best. Yeah, man. Bless up.
All the best to you, sir.
Yeah, man.
Bless up.
She alone in that group? All right, good.
How is it that I am host? How is that possible?
because Mr. Shan gone.
Me gone too. Me end it for all. Bye, people.
Bye.